Here's number 43. It's also number 41, 42, and 44 from the book. Just like the last problem, I said it was number 39, but it was also 37, 38, and 40. Okay, so here's the data for number 43. When our x value is, our x goes from 1 to 8, when our x is 1, we get 695 for y, 410 for 2, and so on. So I've put this data into the calculator, so go ahead and pause the video and go ahead and do that. All right, now the next couple steps I'm going to do, they're not requirements for this problem, but I want to do them for you just to kind of paint a picture. So the first thing I'm going to do is I'm going to check if a linear regression line is a good representation of this data. So I've got my x in L1, x in L2, go down here to, I'm going to store this in y1, okay? Hit calculate. So I want to see if a linear regression line is a good representation of this data. Hit enter. Okay, I'm going to go to my window. I want my x value to be a little bit lower than my x min to be a little bit lower than my x values here. My x max a little bit bigger. My y min is a little bit lower than 68. My y max 700 is a little bit higher. And then I don't like a whole bunch of lines, so I just put 500. I guess it'd probably be more realistic to say go 50. So we'll do 50 here. Okay, I want to graph this. There we go. So as you can see, this isn't a very good representation of the data. We have 1 point above it, and then it looks like we go below it, and we go back above it. So if we made a residual plot, we'd have 1 point above, we'd have a bunch of points below, and we'd go back above. So this data wouldn't fluctuate. Fluctuate means it's hopping back and forth. You got some above, some below, all the way along. And it looks like there's a pattern. Okay, so a linear regression line doesn't do a very good job of this. And I guess we can go back and check to see what our R value, even though I think our R value is kind of high. What was it? It's pretty significant. It's 0.85. That's a pretty high R value. Okay, so this should be a good representation, but if you look at the graph, it's definitely not. So what else? Well, we in the last problem, we did exponent regression line. So let's try that. Okay, L1, L2, and this time I'm going to store this in, because I want to compare the two, I'm going to store it in Y2. Okay, so I have the linear regression in Y1, I have this in Y2. Hit enter. Okay, again, we went a little bit higher here. We have a higher R value, 0.922. So it should be a better representation of the data. And let's check the graph out. It shouldn't have to change anything because our values are still the same. So there's the first one. Look at the second one. Looks like it matches it a little bit better. Okay, but it doesn't seem to be perfect. There's another test we can do, and that's what you're actually supposed to do for this problem. You're supposed to do, when you get to a problem like this, you're supposed to do the power regression. This is for equations that are, this is the exponent one, okay? But this one is y equals a to the x to the b, okay? So that one's called the power regression. That's the one we're going to try here. Let's just see if we can get a little bit more accurate. Okay, so I stored the linear regression in L1, the exponent regression in L2, exponential regression I should say in L2. Now this power regression, I'm going to store that in Y3. I misspoke. Y1 and Y2, not L1 and L2. Anyways, you get the picture. So here we go. Y3. Click calculate. We got a higher R value here. 0.91 last time, 0.85 before that. So this should be a much better representation of our data. So there's the linear regression, there's the exponential regression, and look at this. The power regression matches it almost perfectly. Okay, so I think for the question it asks you to make note, you can make a scatter plot. So here would be your scatter plot with your linear regression. So I hope this helps. This will show up in the later problems online.